In this video, I'm going to show you how to take data, raw data, and use a data table to calculate the appropriate measures of central tendency and dispersion for variables of different levels of measurement. Remember that you can only calculate certain statistics depending upon the level of measurement of the variable. So for this particular example, let's look at our data here. We have data from an online dating site, and we have three somewhat cryptically labeled variables. Why do I say cryptically? Because we don't know what this means. We need a code book. Okay, so in this Excel workbook, I've given you a code book. It's in the next worksheet right down here. And here I'm telling you the variable and its label, and then also the code that's been given to it. So size, actually, is this question: which is bigger, the sun or the earth? Okay, and if there's a 1 in the other, so this 1 here would indicate sun, and the 2 would indicate earth. Okay, this is a very good question to ask of someone to, I think it's a proxy for a lot of different things. So sun is 1 and earth is 2. So that's what this question is getting at. The same for income. How important is income in choosing a partner? So ranging from 1 extremely important to 5 not at all important. Okay, so there's values of 1 through 5. And children, how many children would you like to have? From 0 to 5. And also for this one, there's a no answer category, and that's been coded as 99. And for this one, there's a no answer category, which has been coded as 3. So, as I said previously, the level of measurement of the variable is going to determine the statistics we can use to analyze it. So I think it's good to look at the level of measurement of each variable. So this one right here, which is bigger, sun or earth? These are not numbers, these are categories. So even though the codes are numbers, like all of the codes in your GSS data, these are actually categories and they cannot be ranked in any meaningful way. So this variable would be nominal. The next one, income, you can see that these are words, right? They're not numbers. However, they can be ranked. There's a pretty clear ranking from the most important to the least important. So this one would be ordinal. And finally, children. How many children would you like to have? This is the number of children, right? So 0, 1, 2, 3, 4, 5 children, which is also another very important question in finding a partner. You want to know how many children they would like to have, and you should tell them how many children you would like to have. And then also a no answer category here. So we want to make sure that we're excluding these categories here when we do our analysis. Okay, because when we exclude these categories, in this particular case, excluding this category is going to make this an interval level variable. All of them are numbers except for this category. So when we do our analysis, we want to exclude this data if we're going to do any numerical calculations on the actual numbers. So this one would be interval level. And as in all workbooks, you can see where we're going here on the red tabs, and in the blue tab is where we are. So the first thing I want to point out here is that Excel has the capability to interpret things as data. Now, what do I mean by that? So these are just numbers, but Excel can actually interpret this as a data table. There's a couple different ways of doing that, but I think the easiest way is to just hit Control T, as in table. And before you do that, you just want to make sure that there's white space around your table. The table could be up in the corner, that's fine too, but you just want to make sure that there's nothing adjacent to the table, above, to the right, to the bottom, and to the left. And click on any one individual cell. If you do this or that, it's not going to work. Any one particular cell, and hit Control, and then hit T. So holding in Control, and then I'm hitting T. Then up comes this dialog box here, and you want to make sure that my table has headers is checked. That's going to ensure that these labels here can be of some use to us, and they're not going to be interpreted as data themselves. So Excel automatically guessed where the data is because it's totally separated from anything else. I click OK. Now you can see what Excel has done here. It's done some pretty interesting things. There's these arrows here, which we'll be using in a moment, and it's given it some nice little formatting, which is always good. And if you highlight this table, it has a name. Okay, so if you click anywhere in the table, actually, you can see where in the Table Tools tab appears. If you click anywhere else, it goes away. It's gone. Anywhere in the Table Tools tab appears. Anywhere else, it goes away. So what I'd like to do, there's a table name box right here, and I'd like to give this table a meaningful name. So I'm going to give it the name dating. I'll hit enter, and now this table, as you can see, has been given the name dating. That'll be useful for us later in referencing this table and then also the columns as well. So the first variable I'd like to look at in this case is going to be size. So again, recall what this question says. It's about the size, which is bigger, the sun or the earth. So what I want to do is I want to calculate all of the statistics that are appropriate. So we know our statistics that we can calculate: the mode, the median, the average, the minimum, the maximum, which are going to give us the range, and the standard deviation. Okay, and we looked at some of these formulas in a previous video, and now we're going to add some more formulas. But first of all, because size is a nominal level variable, we know that we cannot calculate very many statistics. The one that we can calculate is the mode. That's the only real statistic we can calculate for a nominal level variable. But if we want to exclude the data, remember the 3's were no answer. So if we want to exclude the 3's, how can we do that? Well, because we formatted this in a data table, Excel gives us the opportunity to do that. So previously we had used this formula here, but if we click on this little arrow here, Excel is going to help us filter the data. So it's selecting all of the data right now, but we can have it only display particular data. So I only want to display the 1's and the 2's. I don't want to calculate frequencies for the 3's. So I can uncheck the 3 and click OK. And now you can see that all of the 3's are gone. Now, a couple really interesting things to note here. First of all, there's this filter here. It's telling you what's happening. It's only filtering for whether it equals 1 or 2, and the 3 is filtered out. Okay, so it's telling you something is going on here. And there's another signal to let you know that filtering is occurring. If you look over here, the rows of the table are highlighted in blue now. They were not before. You can go back and check. 7, 8, 9, 10, 12. What Excel has done, it's hidden the rows, but they're still there. Okay, it's hidden the rows, but they're still there. And that's an important distinction, whether the rows are still there or not. Okay, so because the rows are hidden, we have to use a special formula to make sure that we're not actually including the hidden rows in our calculations. Okay, and for the mode, that formula is the aggregate function. So let's go ahead and do that. So if we type in equals aggregate, now it's telling you all these functions you can use, and the one we want here is the mode, which is the same exact title as before, but now it's within the aggregate function. And that's going to give us a number 13. That was just the 13th item in the list. There's no special meaning to that. And now it's telling us to enter a comma. And what we want to do is we want to ignore hidden rows. Okay, this is going to filter out all of those rows that have been filtered. So I'm going to click on that, and it inputs the 5, comma. Now it wants your data. So at this point, there's a couple ways you can do this. You can do this just like before by selecting, and I'll go ahead and do that. But you can see Excel has automatically guessed, it knows this is my data table, and because I've selected this, it knows that this is the table dating and the variable size. So these options are actually available to me if I wanted to type them in at any time, and it'll prompt me for them. So I start typing in dating, and then there it is. Because I entered it up in the table name, now dating is here. And now I can hit a opening bracket, and it gives me the 3 different variables I can choose from. So you can do it either way. You can select them, or you can type it in here and click on them. Whichever way works for you is fine. But this is another option that's available to you. And I'll do the closing bracket and the closing parenthesis, and hit enter. So it's telling me here that the mode is 1. So what does this mean? Okay, so the mode is 1. Remember, 1 means the sun. So for our interpretation, I'm going to make sure that we write out the mode is actually sun. Okay, it's the actual word. Don't just give the number. The number is just a code for this word, sun. So our interpretation for this would be, with respect to the size of the sun and the earth, more people said that the sun is bigger. Which, if you've taken elementary school science, it is. The earth goes around the sun, right? But actually about 10% of people think it's the other way around. In any event, can we calculate these? No, because for nominal level variables we cannot calculate the median or the mean because they are not ranked, so there's no middle number, no middle category, and we cannot calculate the average because they're not numbers. Okay, so these are going to be no, we don't want to do these. We'll X them off. And the same thing with all of these measures of dispersion. We can't calculate them because there's no greater or less than, so it doesn't make any sense to talk about the spread of our data. And the same thing with skew. So another thing to note, as I say down here, is that when filters are applied, the regular functions will not work as you might expect. Now, I'll show you why that is in just a moment. As I said, it's going to actually include the hidden rows in your calculations, which is why we use the aggregate function. But if we want to undo the filter or create another one, but want to retain the original value that we calculated, so for example, the sun, the 1 up there, we must first do a special paste as values, or just type the number in. Now, what do I mean by that? I mean that if I undo this filter, it could include the 3's in my calculations that were here. It's not going to make too much of a difference here because not many people didn't give an answer to that question. But it will make a difference for some of the other ones, and we'll see why. But what I mean by the copy and the paste is you can copy something and then paste by doing right-click. And there's different pasting options, okay? And what I'm saying is you can paste it as a value, and it's going to get rid of the formula. So if I just do a regular paste, you can see that it still has the formula there. But if I delete that, copy, and I right-click, do a special paste, the number is just going to put the value there, 1. Okay, there's no formula. So then if I undo the filter or change any other filtering options, so for example, if I decide to filter, I only want to look at the yeses or the nos. Let's look at the nos. You can see that this is going to change, right? Because I'm only looking at the subset of the data. But the 1, this is not being used in a formula. Okay. So now I'll undo all of my filters. Now you can see there's no more filter symbol up here, and these rows are no longer blue. Alright, so let's move on to income next. So we're going to do the same exact thing, but for this particular case, if we look at income, going back to the code book, there's no missing data actually. Everybody answered this question in the appropriate way. So there's no missing data, so we don't actually need to use the aggregate function. We'll use it for our calculation for children, but we don't really need to use it now. And this will prevent us from potentially making errors, because again, regardless of whether or not we're using a filter for some other column, it's actually going to keep all of those hidden in the calculation. So let's go ahead and just do the way that we've done this before. Mode single, hit the tab button, and then I can type in my numbers, but I know that I can type in dating, and I want income, close parenthesis. Okay, so the mode is 2. Now what is 2? Going back to our code book. 2 means that the respondents said that income is a very important aspect of choosing a partner. So the mode is very important. So the most common response was that the income of a romantic partner is very important. Okay, so we're done for income. Now let's move on to the median. And again, I can use the same exact formula. Equals median, dating, and income, enter. And it's telling us that the median is 2. Now what is that telling us? It's the same exact thing as above. That means very important. So we can say that in terms of the income of their partner, the response, very important, split the distribution in half. And that's what the median is telling us. And now for the average. Can we calculate the average? Going back to our codebook, we had just typed that this is an ordinal level variable. These are not numbers that can be averaged. Okay, these are not numbers, so we cannot actually calculate an average. So no. Can we calculate a minimum? Yes, we can calculate a minimum. And we can calculate a maximum. Now you might think that, oh, well, the minimum and the maximum, there's just going to be 1 and 5, but not everybody necessarily says all of those items, 1 through 5. So we can actually type in min, dating, income, close parentheses, enter. The minimum is 1, and the maximum, dating, income, is 4. So if we look up at our data, there are actually no 5s here. So what was 5? 5 was not important at all. Okay, so I guess everybody in the sample felt that income was somewhat important. Not very important, but at least a little tiny bit. So this is not at all, not very, somewhat, very, extremely. The range was from these 4 values, not including the 5. So we can say that regarding the income of their potential partner, answers ranged from extremely important to not very important. And standard deviation, we cannot calculate. If we can't calculate the average, we cannot calculate a standard deviation, because the deviation, it's a calculation of how much something varies around the average. And if there's no average, we can't calculate a deviation from that average. And the same for skew. Cannot be calculated because we did not calculate a mean. Now for children. Now here let me demonstrate what would happen if I know that 99 is missing data. So I'll unselect the 99. That means they didn't answer the question for number of children. And I'm going to input, let's pretend that I forgot that I have to use this function. Okay. And I just use the other ones. Now what this is going to do, this will be most apparent for the average, so let me do that here. If I were to type in average and were to do dating children, enter. 12. Wait, none of these numbers are more than 4, right? How could this be 12? Oh, okay. So what's going on here is that it's actually keeping this 99 in the function. Okay. So regardless of whether I'm filtering this or not, this number is going to be the same. So this is the reason why we want to make sure that we're using our filters and then we actually use these other functions. So so this is going to not ignore the filters. It's actually going to take them into account, these functions. And if these functions actually ignore the filters. Okay. So the average is one example of a function that ignores filters. So we actually want to use our aggregate function, and we want the average, which is 1. And we want to ignore hidden rows, 5. And our data is dating, bracket, children, close bracket, close parenthesis, enter. Okay, that seems more reasonable. Okay, the average number of children is not 12. Okay, so the average number of children is 2.29. So let's interpret that here. So we can say the average number of children that the respondents wanted was 2.29. So for our median, I can use the same formula I've indicated over here. Aggregate median is number 12. I can type that in, comma, number 5 to hide the missing rows, comma, and our data is dating children. We're not dating children, but that's the name of the variable. And our median is going to be 2. That indicates that in terms of the number of children that respondents wanted, the number 2 split the distribution in half. So there's a number of people who have children under 2 and this number who have over 2, but the number 2 is the middlemost category here. Okay, and similar to before, we can actually, there's 2 different ways of copying this. One will work and one won't. If I just do copy and paste, you can see that this has size in it, which is not what we wanted. Okay. If we do use the dragging method, I would drag over that and that. This is going to actually change these to what we would expect. So we wanted to copy over from size to income to children. So that's just one thing to be careful of when you're copying and pasting, that these table references don't necessarily copy and paste in the way that you would expect. Okay, so I can hit undo and show you again that when I just copied and pasted, it pasted the actual formula, not the actual relative reference. Okay, whereas when I drag it over using the little black box, it actually made that happen. So there we go. And I can drag it for this one, and if I do that, I just want to make sure that I have my filter off for this particular one here. And you can see that with the filter off, this value changes again. And again, this is why you want to make sure that you're typing it into the cell so you remember what it was. Okay, the value. Because this is going to change. Otherwise, you could keep the filter on. So filter that. And you could copy this and then paste it somewhere using a special paste. Paste as a value. And you can give that more room to see the digits. Okay, so now let's move on to finally calculate our measures of dispersion. So this one, I'll go through these a little more quickly. Aggregate, and now we're looking for our min, which is 5. 5 is going to give us our ignore hidden rows, and we want to use ding children. And the same thing here, I can copy and paste this. I know that all I want to change here is this 5 to 4. And 4 is going to give us the max. So what we can say here is that regarding the number of children wanted, responses ranged from 0 to 4. And this is an actual number, so we're going to make sure we keep the units 0 to 4 children. Okay. So for standard deviation, we can just use this formula, equals aggregate, open parentheses, standard deviation. We're going to use standard deviation P. Okay, because we're saying we're just interested in the standard deviation of these particular people. We use the sample one when we're trying to estimate the standard deviation of a population. But if we're only interested in the people in the sample, we would use standard deviation P. So that'll be 8, 5 to hide the rows, and we're looking at dating and children. And the standard deviation is telling us that on average, the number of children that people wanted differed from the mean by 1.13 children. Now, again, remember to round. When the 5, when this digit is 5 or greater, you have to round. So we're doing to the 100th place round. So that's actually important. Otherwise, you're systematically underestimating everything. So that's why we round. And for skew, we can just say, now we do have a median and we have a mean. So we can say that since the mean, which was 2.29, is greater than the median, which was 2, the distribution is positively skewed. And that's how you calculate your measures of central tendency and dispersion from raw data. And remember, to create a table like this, you just click on any one individual cell and press Ctrl-T.